Welcome to the Schneider Electric webinar series. My name is John Weber. We're going to be presenting adding battery-based backup to a existing PV system. And what we mean by that is that there are several different ways that we can bring about bringing energy storage into a solution, either through backup power, AC coupling, or even doing a retrofit after the fact, and bringing in DC coupling. During the course of this webinar, we'll be talking about some of the basic design considerations, which includes maybe why bringing storage into a solution makes a lot of sense, as well as talking about choosing the right inverter based on what the needs are, if it's going to be a Connext SW or Connext XW Plus, just depends on what the needs are for the site, as well as just understanding when we get to energy storage, what is the right amount. And there's a couple different concepts we'll talk about with storage, as well as touch on advanced storage as well. And then we'll talk about a couple sample bills of material that will help bring all that together. So why do we even want to bring energy storage into an existing PV system? There's a lot of good reasons to choose that. It could be that there are some environmental factors, where the location of the home is or the solution is. It could be that there are concerns about where that power is going to be coming from now and into the future. Of course, a lot of customers realize that along the way when they have their first power outage that PV system up on the roof is not working. And so they have a little bit of buyer's regret. I'm sure it was already explained many, many times that when the grid goes down that the PV system's not going to work. And so that's where we can bring in that energy storage along with that grid forming inverter and be able to bring that system together. Of course, again, those concerns for the future. Is the grid going to get better? Is it going to get worse? And that can vary from location to location throughout North America and even throughout the world. And then finally, how can we use that energy storage to get more out of the system? We look here on the graph on the right-hand side. We can see that in a lot of locations, the time of day is going to determine the cost of power. And when we get around the 20-cent mark for cost per kilowatt hour, energy storage financially actually starts to make sense to offset. So if we look at the graph here, it gets as high as 34, 35 cents a kilowatt hour in this example. And that 15-cent difference is enough to say that cycling those batteries using energy storage on site makes a lot of sense. But when we get into that, we need to understand that that is going to be a DC coupled system, just simply because charging is pretty complicated when it comes to doing an AC coupled system that's already connected to the grid. So finally, with the frequent power interruptions, we're talking about, of course, winter storms, locations of power lines, and finally brownouts, and whether or not the quality of grid's going to be getting better or is it going to be getting worse. So when we talk about and compare AC versus DC coupling, or which one's the right solution, a lot of times AC coupled solutions are going to make an ideal retrofit, just simply because they're very, very cost effective. It just simply means bringing in storage along with a grid forming inverter so that system can wake up. And of course, if consumption is primarily during the daytime hours when the sun is shining, it is the most efficient way to use that array up on the roof to consume power. We talked about that slide previous with that 34 cents a kilowatt hour. Of course, if the time of use and the time of production are lined up perfectly, then staying with an AC coupled solution can be the best way to go. When we look at DC coupling solutions, of course, this is where we have complete control over the charging of the batteries because we'll be using a solar charge controller versus AC coupling, and we'll be able to dip into those batteries and recharge those batteries when we see fit. And that really opens up that window for leveraging that time of use, and especially something like self-consumption. When we talk about DC coupling, of course, we're able to do a 3-stage charge, which for lead-based storage technology and even a lot of advanced storage technologies, that really is the ideal way to charge the batteries. We'll touch on that a little bit more. But the option that comes with DC coupling is obviously the most versatile option that we have, just simply because we have complete control over the DC charging source. And so we really can leverage not only a lead acid battery, but there are some advanced storage options that really do need to have a lot more control over the charging source. And with AC coupling, we're pushing power through the grid forming inverter onto those batteries during a power outage. And unfortunately, that doesn't necessarily leave us with the best charging characteristics. There are certain advanced technologies that aren't going to like that very much. We'll touch again on that a little bit later. But DC coupling definitely brings the best solution possible for that system. So let's examine what an AC coupling retrofit looks like. Under normal circumstances, of course, a PV inverter is going to be attached to the main panel and is just simply going to push power out onto the grid. When we look at a AC coupling retrofit, we're actually putting the output of the PV inverter on the output of the Connex XW Plus here in this example. And so with that sub panel, we are going to have basically two possible sources for an AC sine wave for that PV inverter to wake up. Of course, under normal circumstances, the PV inverter is just simply going to see the XW Plus as a piece of wire, because when the XW Plus is connected to the grid, it's in what we call pass-through mode. So it's just a piece of wire that's then the inverter is going to pass that power through on out to the grid. And what we need to have happen, though, is because the PV inverter can't create an AC sine wave, we need to have something create a sine wave during that power outage. So what we have here, and what we can see, is that suddenly the grid's gone away. And we know that the grid's gone away because, well, it's not there anymore on the slide. But we have still, after a 5-minute cooldown, that Connex PV inverter is still pushing power out onto the sub panel. And it's doing so because the Connex XW Plus is actually creating that sine wave that's needed for the system. Now you notice here actually that there's still a bidirectional arrow on the right hand side pointing to the battery. So what we're going to talk about a little bit later is exactly some of the charging characteristics that occur during an AC coupling retrofit. But in short, when we're consuming power on the sub panel, we're actually going to have any extra power produced by the PV inverter go onto the batteries. And at some point, those batteries are going to get full and we'll need to disconnect. But again, we'll touch on that a little bit later. The nice thing with this system is, of course, those house loads are going to remain backed up permanently until either the batteries run out of power or the grid comes back, because the PV inverter is going to provide power first to the house loads. But then when the sun goes down, the Connex XW is going to be the primary source for AC power to those house loads, because it is that grid forming inverter there. Of course, another option that we have is with DC coupling. This is where, say, we've either taken out the PV inverter or we've just simply started with a new install. And with DC coupling, of course, we have the Connex MPPT80 charge controller connected to the array and providing a charging source to those batteries. And when that voltage gets high enough, and we know that a charge has been completed, meaning that the batteries have been taken care of, that's when the Connex XW Plus can then begin selling power out to the grid. And the nice thing with this whole solution is that we have absolute control over the charging source from that charge controller. So what happens when we lose power on this solution? Of course, when we lose power on the solution, what's going to happen is that that system is now going to be able to still provide backup power to that sub panel and to those household loads. The really great thing about the XW Plus, of course, is it has dual AC inputs. So it can not only sell power back onto the main panel out to the grid, but if there's a generator there or a generator already on site, then what that system's going to do is be able to call on the generator to begin doing a charging if the batteries can't keep up. And that can be in the middle of the day, actually. If the sun just isn't shining and the loads are large enough, this really does make for a very versatile solution, and also can help keep the cost of storage down, because the generator can actually act as that charging source again and provide that backup power above and beyond just what the batteries can provide. So sometimes if the loads are very large, it financially can make sense to bring a generator in instead of just doing batteries batteries and providing a very, very large source of storage in the form of lead or advanced storage. So we will again touch on this a little bit more because there are some benefits and detractors to this idea, and we'll continue on that path. A third option, of course, is what if it doesn't make sense or it's not possible to be able to do an AC coupling retrofit? So this is where we can actually bring in energy storage along with the Connext SW and be able to just simply provide backup power to those household loads. This can be a very, very easy way to manage a backup system when and if it doesn't make sense to actually bring in an AC coupling solution. So in this example here, of course, we have the Connext SW and the batteries, but what happens when we lose grid? Of course, the Connext inverter or the PV inverter is no longer connected to the grid, so it turns off. But we still have uninterrupted or nearly uninterrupted power to those household loads. And so this makes for an ideal solution when backup is needed, but it just doesn't make sense, again, to do that with an AC coupling solution. So again, with the design considerations and just kind of a little bit of a recap, we need to make sure that the PV inverters has a sine wave or a qualified AC source to inject that current. And that's where that battery-based inverter actually provides the sine wave to initiate and to have that qualified AC source for the PV inverter. And again, you got to make sure that the output of the PV inverter is shared with the output of the battery-based inverter, the Connext SW or Connext XW+. So next kind of part we're going to be talking about is the behavior of the system during normal operation, and also talk about what happens when we have a power outage. With that normal behavior during operation, again, the inverter that's battery based is in a pass-through mode, and that PV inverter is going to just see the grid. At that point, the battery-based inverter is simply a piece of wire. During a power outage, of course, it's going to create that qualified AC source to begin selling power to that AC source, either to charge the batteries or to cover the loads inside the solution or home. When looking at the sizing for storage, this is critically important to make sure that we have enough storage there and that we also meet the expectations for the site as well. When we talk about the SW or the Connext XW Plus, of course, they're battery-based inverters. And the batteries that we're talking about really are either flooded, AGM, or some advanced energy storage. And it is required. You can't bring in a battery-based inverter and expect it to work if there is no energy storage. The inverter literally will not come on. So when we talk further about, now that we have a system, we know that we need to have storage inside of there, what do we recommend for actually that relationship or that ratio? And we have to take into account not only the charging capacity of the inverters themselves, meaning we can't put 16 kW of solar onto a 6.8 kW battery-based inverter. That will literally overwhelm the inverter's capacity. As an example for Trojan, of course, they recommend 10 to 13% of the C20 rate for industrial batteries, meaning that really we're looking at a charge rate of about 5 hours to properly charge those batteries. And with the XW Plus, of course, we would need almost 1,000 amp hour battery bank to use its peak charging. So when the inverter system's in normal operation, or let's say that the grid does come back, that grid tie inverter is going to reconnect to the grid because now the XW Plus is in pass-through. But then the XW Plus is actually going to be in charge of buying power from the grid to charge the batteries. So if you put less than, say, 1,000 amp hours into that system, then you need to turn the charging rate of that inverter down. And same true for the Connext SW as well. There are some maximum charging amperage there, and you just got to make sure that you're sizing that battery bank so that we don't accidentally overcharge those batteries or charge the batteries at too great of a rate, which actually, chemically speaking, is going to undercharge those batteries and could leave them in a partial state of charge, which really isn't the healthiest, especially for AGMs and flooded batteries. Advanced battery storage, depending on the technology, of course, it really is up to understanding what is needed for that system to properly charge those batteries. It could be that a partial state of charge is fine. One of the things that I strongly advocate for when talking about an AC coupled solution is there's an assumption for most installs, and that's this, that it's going to be connected to the grid 99.99% of the time. So what we're talking about is just a few days out of the year or less where that system's going to actually be called upon to do this AC coupling solution, where the grid forming inverter is interacting with the grid following inverter, or the PV inverter. So I typically recommend choosing a float battery, a battery that's actually made to just hang out and sit on float. The one downside, of course, is that we don't get as many cycles. The upside is that we can actually cycle the system as though we're doing nearly 100% depth of discharge. Look over here on the right-hand side, we can see that the discharge versus cycle life, you can see that that green line just going up is just merely representing how far we're dipping into the batteries. You can see at 10%, gosh, look at that, we get almost 5,000 cycles. At 50%, we get right around 1,000. And at almost 100% depth of discharge, we're getting about 350 cycles. So when we do the math on that, 15 power outages on average for 20 years, that's only 300 cycles. So those batteries are still, even with 15 power outages on average, the batteries are still going to age out before they cycle out. One thing that's worth noting within the research that I did for this presentation is battery temperature actually had a huge relationship on how those batteries survive. Even float life batteries can have a shortened life if the batteries aren't kept at about 20 degrees C or lower. Anything higher than that, and we start affecting the battery's overall life as well. So when designing a system, thinking about that system, think about putting it in a place where it is fairly temperature controlled. An outdoor garage that gets up to 90 degrees in the wintertime or in the summertime may be a little too warm place for those batteries. You may need to look elsewhere or figure out a different way of storing those batteries. We spoke in the beginning of the webinar about choosing the batteries and how using a cycling battery could suddenly make sense, especially even with AC coupling, where prices don't really diminish until past when the sun is shining. So we're actually going to leverage the system. And so that's where AC coupling maybe isn't the best solution, but actually changing out that PV inverter to a DC charge controller like the MPPT 80, which is already a high voltage input, can allow you to then leverage the system kind of one step further than just backup. And so if the customer or if the solution is expecting just straight storage, great, fine, that's fine. But if we can use self-consumption, not today or maybe a year from now, it may be worth actually sizing in and using a battery-based solution that is DC coupled instead of AC coupled, so that we can take advantage of a system that's going to charge power and regulate that system completely and in a very smart way. We just don't get that control when we talk about AC coupling because we don't have the ability to necessarily charge from a DC source. We're going to be buying power from an AC source to do charging, and depending on the jurisdiction, that can create some issues. So really, when we talk about what features are going to be used within the system, we have to make sure that we understand what are the expectations now and what are they going to be in 3 to 4 years. By the time you get to about 6 years with a cycling application or cycling batteries sitting on float for that long, we're already starting to lose some of that capacity. So just be sure that when you're looking at or deciding what is the right storage solution, ask yourself, what is it going to be like in 3 or 4, maybe 5 years? And does it make sense to bring in cycling batteries, or does it make sense to bring in some float life batteries and just have it as a backup solution? With AC coupling and advanced storage, we really have to understand what is happening with a lithium-ion solution and remind ourselves that with a battery management system, there's kind of a second set of brains and operations
that are helping to manage the system overall. And there are going to be conflicts, or there could be conflicts within that system. So with AC coupling, we have to be very careful about understanding exactly how that battery management system is going to interact with the total PV solution, especially if the grid isn't there. If the grid is there, then simply it's in a float mode, which is going to be set up by the programming within the battery-based inverter, the Connect SW or XW+. But during a power outage, we don't have any control over the charging onto those batteries. And so making sure that it's sized correctly is one of a few different things that we need to do to make sure that the system's going to operate correctly. See the lithium-ion installation guide at scsolar.com, and that will help kind of give you some guidelines. If it is a newer solution or a newer lithium company, really finding out if communications with Modbus is going to be needed. Very likely the battery management system is going to need to talk to the Schneider XW Plus or Connect SW to make sure that we're properly managing the output current of that system and that we're not accidentally overcharging those batteries. There are, of course, a lot of other advanced technologies that are out there. And again, the general recommendation is really have a conversation with the battery manufacturer about how they're going to manage or what they're going to need with that system. You may find that they can accept a higher charge current, which allows you to put a greater amount of storage or a greater amount of PV onto the system. Or you may find out that it has a very particular charging cycle that can't be met with an uncontrolled charge. So you really just need to make sure that you do your research. And we do have some experienced distributors and installers that can definitely help out with that. So reach out to your distribution for the Schneider product line or Schneider Electric product line and make sure that you understand what needs to be done to properly manage whatever storage you're going to bring in there, even lead. So we touched on this already, but it's worth reiterating again. What do we expect from a system? Of course, during normal operation, the Connect SW or XW Plus is simply going to be in pass-through. There is going to be a little bit of a float charge on the batteries, and again, depending on the technology of the batteries, they have different self-discharge rates, and that self-discharge rate is really going to describe how much you need to put back into those batteries every day to make sure that we're float and maintaining that storage. During a power interruption, of course, what backup loads are going to be supplied? Of course, first from the PV inverter, that power is going to come if the sun is shining. And if the PV inverters can't keep up, then what's going to happen is that the battery-based inverter is going to inject current from the energy storage solution onto those loads. Of course, if the sun is shining and we have a greater production from the array than we do have consumption, then that's when we're going to begin charging those batteries. And hopefully there's a very nice balance there so that whatever the system consumes, let's say we have a 2-day power outage, and that system throughout the evening, of course, consumes power, and on the next morning, the batteries are going to be low. And so we have enough extra PV to actually charge the batteries while covering the loads inside the home. So again, when understanding how much PV to put into the system, we really need to make sure that we're sizing for daytime loads, and we're also sizing to make sure that we can cover some charging into those batteries as well, all the while making sure that we don't accidentally overcharge those batteries because we're pushing too much current onto them. And when I say overcharge, I mean push too much current onto it, which interestingly, again, leaves the batteries perhaps in a partial state of charge because we've charged them too quickly. So a lot of things to kind of juggle around and make sure that we find that balance. And it is a careful balance that needs to be done through some analysis of the loads as well as in the nighttime and the daytime. What is that right project? When we understand the expectations of the site, that's when we can begin to mold them and make sure that we bring everything together. So having a conversation with who's going to end up owning the system is very, very important. They've already got PV. They want to be able to add a battery-based system to it. Are they okay with just having 12 hours of backup and they don't want to generate it? Well, that's very easy to do. And may save a lot of time and effort with doing an AC coupled solution, or maybe that they expect several days of power outage and they want to leverage that PV inverter solution to get as much power to charge the batteries and bring that total solution together with AC coupling. Of course, if an energy audit's already been done once, and I would assume that somebody who's done a PV install is going to be aware of their production consumption numbers anyway, going back through and doing a second energy audit, identifying any leftover high power loads. It could be some incandescent bulbs that kind of got missed or got put in, let the customer know, understand that the site needs to go back through and do that. So if you think about, as an example, a 100-watt bulb that's an incandescent, and then you switch them out to CFLs throughout the home, well, maybe now it's time to spend a few more dollars and go with complete LED replacement. And the cost that's spent on putting in LED lighting is, of course, going to reduce that overall sizing for the system, both for energy storage as well as AC coupling, and so can actually really have one of the greatest impacts on reducing the overall cost of the system just by simply modifying or limiting the amount of loads that we put onto the system. And that's really where it comes into understanding the loads. Again, what are the expectations? And if we can mold those expectations time and again to reduce those loads down to what is truly necessary during a power outage. Again, a great way to create a system that becomes very, very cost effective so that we're not worried about how much is left to spend on this AC coupling solution. We can move forward with a very neat and tidy cost to that overall system. Anyone's already attended a battery-based solution webinar, seminar, or whatever, of course, sizing is always talked about. The fridge, freezer lights, TV, making sure that if the house is heated, either hot water or the HVAC system is gas heated, the loads that are part of that solution actually can be incorporated into the backup, and so the customer can have a hot shower and a warm house while they're waiting out some sort of event that's caused the power go out. Of course, we have to understand that there's kind of two different loads. There's resistive loads, which is typically heating, old incandescent bulbs, which of course we don't want to use. But anything that has an inductive load to it, we also have to make sure that we're sizing the inverter for those surges. Some examples would be, of course, the fridge and the freezer. Both have electric motors that spin over compressors for the refrigerant, as well as the blowers themselves inside of the gas heating, either HVAC or even hot water, can have a blower on them for exhaust. So things to be aware of when sizing the system, make sure that we take into account any inductive loads, because if those come on especially kind of all at once, that could overwhelm a smaller system. So we just have to be aware of that. One of the things that I've kind of taken up is this idea of good, better, best solution. And this really is about sizing the system to meet the customer's needs in a different way. We can spend a tremendous amount of time making sure that we size everything out, but a home is a living place. And we can see there on the diagram on the right, we got vacuum cleaners, we got hair dryers, we have a lot of different potential loads inside the home. And if you notice, a lot of those things get plugged into the home. And so we don't necessarily always have a control over what gets plugged into the home. Somebody could go run a space heater that's 1,500 watts and consume power at an exceptional rate. So by setting up a good, better, best idea, we kind of use this analogy of a hot water tank heater. If you have two people who take 10-minute showers, they're literally never going to run out of hot water because they take the shower and the next person takes a shower and you're done. We have plenty of reserve energy. But if, let's say, we have 5 or 7 people inside the home and they're all taking 10-minute showers, very likely the last few people are actually going to take a cold shower. And so that's the same sort of idea that we talk about energy in a good, better, best solution. You consume it and then it's gone. And as long as the customer understands that, they also understand that the power that they're consuming has a relationship to how much is left over at the end of the day. And we need to make sure that we're providing this good, better, best solution. Good being, yeah, we can cover it for 12 hours, Better would be, of course, we're going to get you through the night. The PV array is going to come around and we'll start charging again. And the best solution could be, a couple days of stored energy. And this would assume in a lot of ways that we're not actually able to charge the batteries from that solution. That the batteries for a couple day backup would actually be able to exist without any charging. So that's really the only way we can size it. So sculpting those expectations again to make sure that the customer or the site understands exactly how they consume power, has a relationship to the amount of energy left over, and they can be part of the conversation with that good, better, best idea. Common loads for backup power really determine the size of the overall system and the needs to branch off for the PV inverter system. A lot of the common loads, of course, are those fridge, freezer, lights, TV, well pump. One of my favorites is don't forget the garage door. It, of course, can result in not being able to get the car out. Other ones are, of course, fish tanks, if they're kind of the exotic style fish that can't really go without their circulation pumps and whatnot. Phone systems, internet, and typically power outages can come some pretty ravaging storms. So make sure that the sump pump is also wired into that. Over on the right-hand side, we can see that there are some sizing calculations. They're just basic numbers to give you kind of an idea of how to size. There's a lot of resources online for these sizing sheets. A quick Google search will help you find those. For the refrigerator, just as an example, of course, it's a 1 kW load. But when we're sizing out for the system, we have to remember that the fridge maybe only runs for 15 minutes a day, which is what that 0.25 is. So really, it's only about a 6-hour load or 6 kilowatt hours of consumption. So just something to keep into mind. And of course, we have these CFL lights, and I've advocated for and will continue to advocate for taking CFL lights out and going with LED lighting. Again, the more that you spend on conservation, the smaller the system needs to be overall. One of the numbers that is going to move around on you are receptacle loads. And here in this example, of course, we have 300 watts at 16 hours. But those numbers can move around. So make sure that people understand, again, that conversation to make sure that whatever they plug in is going to be consuming that power. So just because it didn't get sized in as a receptacle load, receptacles accept anything, we need to make sure that we're not plugging things in that didn't get sized for or those expectations been set, that if large loads get plugged in, then we're going to consume power sooner and faster, and that means that the battery bank may need to be larger if that's what the customer is going to do. So for loads that we want to avoid, really this comes down to the items that are things that are nice to have but maybe shouldn't have when sizing out an appropriately priced solution. Pool pumps, circulation pumps, and things like that, of course, are big draws and have lock rotor amps. Heating with electric is a huge no-no when we're sizing that system out. Hot water tank heater can be a 6 kW load, and HVAC, if we're heating with electric, of course, is going to be a high consumption as well. Need to be aware that things like coffee makers and toaster ovens, while used infrequently, can be a great way to do it, but a coffee maker left on for a great amount of time is going to continue keeping that pot of water hot and could make for a surprisingly large load over time. Some of the other things that are kind of gotchas along the way are those large outdoor lighting and some bathroom conveniences, meaning hair dryers and curling irons and things like that. Also need to understand if the automatic lighting for a home makes sense or does it make sense to put in sensor movement lighting. And so if you have like dusk till dawn style lighting, again, spending a little bit more on movement sensors so that they only come on when they sense movement may be a way of, again, reducing that overall size of that system instead of just going with automatic dusk till dawn lighting. Very often we see comparisons between generators and battery-based systems, and exactly what does that mean for the overall system. So for battery-based solutions to provide better efficiency, we can actually bring a generator in connected to either the Connext SW or the XW Plus. And what it's going to do is actually allow that generator to come on only when it's needed and turn off once those batteries are charged. So it's a great way to support the system, especially if there's one already on site. There's also a couple of examples where bringing in a generator can actually reduce the cost of the size of the system overall, because maybe there are some loads that are quite large but are important to the customer regardless. And what we can do is actually bring in a generator to supplement the amount of or the size of the energy storage solution. So this can create a great kind of cooperation between two different technologies for providing AC power inside of it. One thing that I do like to mention, kind of 2 points. One is that when we talk about the generator itself, make sure you do a little research and that the manufacturer doesn't say that you can't use a generator as a charging source for batteries. I ran into that on a couple different manufacturers, so double check the warranty if you are going to size it in, or if the generator's already there, make sure that that battery-based system can be compatible for warranty issues. And of course, we want to make sure that there's only one neutral to ground bond. Typically, you can find that the generator comes automatically with a bond inside of it, and you'll need to remove that because you can only have one ground bond inside the system. So just a few things to note. And of course, probably one of the greatest benefits of choosing the XW Plus is that it has that dual AC input, so that you can actually set up charging parameters and how that system uses those two inputs distinctly, needing that the grid source can provide maximum charging and everything else, but maybe that second input has some load support functions to it as well. So you don't necessarily have to size for a 20 kW generator just to make sure that everything fits. But our general recommendations is to make sure that it's at least the size of the inverter so that we can cover loads as well as do some charging. The worst case scenario would be if we chose that generator and that generator is only a 4 kW generator, let's say, and we have 4 kW of loads. That XW Plus will continue to be in pass-through mode and never be able to charge from the AC source and get that generator turned off. So making sure that we have an appropriately sized generator so that we can provide both charging and for the loads at the same time is critically important when looking at and understanding that system and how to kind of bring it all together. The general costs with associating a generator, and sometimes it's a compare and contrast between choosing a battery backup system or a generator when we can't bring in a generator and a backup system using batteries just for whatever reason comes up. Install cost actually ends up being pretty darn close to cost for a battery-based system. Beyond that, of course, then we have the LPG and cost of maintenance per year. With a battery-based system, especially with those float life batteries, there's very little maintenance cost that's associated with that system. So if you take the 10-year cost into account, suddenly a battery-based backup system has a lot of benefits. The one detractor that's worth mentioning, of course, is that typically with an LPG tank, 100 gallons or something like that, you can get quite a bit of use out of that. So there's some compare and contrasts there. The $3 per consumption was based on some numbers that I pulled from New York State, which displays their different costs for different regions. This was actually fairly middle of the road. So you figure out what it costs per kilowatt hour on a system, and it could cost up to 54 cents per kilowatt hour. And then, for a generator to really supply power on a 24-hour basis, that generator just sitting at idle is going to cost really what it costs to buy 1 gallon of fuel. Something that typically is true for customers who are looking at using a PV system that's already installed is just that cost of CO2. And just a generator per gallon is going to be producing about 12.7 pounds of CO2. So just another part to take into account when choosing and getting all the facts put together for when it makes sense. Of course, when a generator is running just to keep the lights on in the middle of the night, that's where that kind of generator idle number comes into account, just to keep those lights on inside the home, to have the convenience of being able to flip on a bathroom light in the middle of the night, can cost several dollars that evening and can produce quite a few pounds of CO2 in the process. When we look at using a generator with an AC coupling solution, there's a few things that have to be taken into account when putting that system together. Of course, with AC coupling, we have to be aware that a generator is or could be a qualified AC source. And as we already talked about, any PV inverter that is grid following sees a qualified AC source, it's going to begin selling power to it. And the last thing we want to do is sell power to our generator because of the risks that are involved. So what we suggest doing, and this is within the AC coupling white paper that Schneider Electric has, is that we actually have a disconnect switch so that when the generator's running, we're actually disconnecting that PV inverter. And once the generator is switched off, then we reconnect the PV inverter. So it's an or statement. Either the generator is connected to the charging source as the charging source for the batteries, or the PV inverter is. You can't have both. There are some special applications, but we won't get into that. Again, that sizing for the generator, and the thing we want to note is that it should be at least the size of the inverter. We size the inverter for the loads. We should size the generator at least for that. But we want to make sure that if the batteries get low, that the generator just doesn't simply take over the amount of power that's being consumed, which means that we'll never actually get any charging done and get that system turned off. So ideally, if we can double the size of the we can double the size of the generator, then the generator is going to be able to provide not only for the loads, but also be able to provide for charging for that system. When we compare a PV solar solution with energy storage and a generator, that cost over time is one of the things that should be taken into account. Of course, a generator has annual maintenance that needs to be done. A battery-based solution, especially with a long float life AGM style battery or gel battery, actually has a very, very low maintenance cycle of just every few years. You're rechecking the connections and tightening things down and things like that, whereas a generator has oil maintenance and everything else that's associated with putting that generator and implementing it. Of course, a generator has a depreciating value, whereas a PV solar system with energy storage can actually have an increasing value, as it can be used for things like time of use, self-consumption, peak and load shaving. We already talked about it once, but it's worth mentioning again. Of course, inefficient use of the resource, that generator has to run 24/7 just to be able to provide that equal convenience that a PV inverter does. PV inverter, of course, only draws the power that's necessary to run the loads, whereas a generator has to have a minimum consumption just to make sure that it can provide something like a night light or just intermittent power. So it's really not the best use of an energy source compared to a PV system. And of course, if you are able to bring both the generator and a PV solution together in one site, you actually get the benefits of both. Probably the most notable ones, of course, is that with a generator on site, we can reduce the size and really the cost of the storage solution and let the generator actually take over some of the consumption of power and as well provide that extra charging for the system overall. So how do we choose the right inverter? Schneider Electric actually offers kind of two different styles of inverters with the Connext SW and the Connext XW Plus. The Connext SW really is the most cost-effective solution to a customer who maybe has some buyer's regret or didn't really understand that when the system goes down, meaning that the PV inverter no longer has a qualified AC source, it doesn't produce any power. The SW, of course, has some really nice programming and can really provide a lot of the same things that the XW Plus does. And in particular, the one thing that the Connext SW has is that it doesn't have a cell option. And so if there's a restriction in the area that says, hey, you know what, we can't connect a grid-tied system then the Connect SW really fills in that gap. Of course, we have a lot of room for growth. The SW can have a second inverter added to it quite easily, and that max pass-through of 30 amps. The other nice thing with the SW is it accepts a single 120 source, so you can bring in a single-phase generator, and the Connect SW will handle that nicely. On the other side, the Connect XW Plus has those tool AC inputs, which really allows you, with that internal transfer switch, to choose between one AC source or another. Programming capacity of the XW Plus and its capabilities are noteworthy, with just the amount of different ways that you can choose that system, and you can do a three-phase solution as well with the XW Plus. Of course, the XW Plus does have the capacity to sell power back to the grid, and so that can create an interesting dynamic with AC or DC coupling. You can mix the two together, but there are some caveats that we won't go into on this presentation. So yes, you can add more solar into the future. The other thing is to note that it can have a single 120 output. It is 120/240 natively without any programming changes, and can also be stacked into a 120/208 three-phase solution, and depending on the size of the system, you can actually bring up 9 of those into it. So very large solutions are possible with the XW. So you've decided to do a system, and what do you need to bring that system together? What are the parts that are needed for this? So here we show the equipment for the XW Plus NA. Of course, you're going to need a load panel, and you will need a little bit of extra equipment to do that AC coupling. In particular, with the XW Plus, you can see the part number there, and there on the right-hand side, we have an image. I'll kind of just walk through what those are. Top left corner, of course, we have the XW Plus. And to the right of there is the PDP. I do give the part number for the mini PDP, just in case you decide you want to keep a little bit more simplified solution. The really nice thing with the PDP is that it allows for up to 3 inverters into it for 3-phase, or if you're doing a split-phase system, you can bring 2 XW Pluses into that quite easily. Mini PDP's focus really is for a single XW Plus. To the right of the XW Plus is the PDP, and a little bit further to the right of that is the MPPT 80 charge controller. Underneath there on the left-hand side, directly below the XW Plus, is a conduit box which allows you to route all your wires as well as offers shielding for the communications. We show a few breakers there, including the DC disconnect breakers as well as the input and output breaker set. Over on the left-hand side, of course, in that dark square, we have our very nice AGS solution, so we can start and stop generators with different programming. The SCP, really up to you if you decide to use this. It's not absolutely necessary, and I'll tell you why here in a second. In the center there, we have our battery monitor. Anytime we use batteries, I always recommend using the battery monitor system, just simply because being able to manage the system, even if it's on float, we can get data logs out of there. We can set up the batteries to get the right charge every single time. And just to the right of there, of course, we have the COM box. Definitely recommend using the COM box, which allows for Insight, which is Schneider Electric's online monitoring. So there are some people using the Zambus communications, which is our protocol for stringing everything together to talk. You can have both the SCP as well as the COM box in that same solution. So you can have on-site programming as well as remote monitoring and data logging. The COM box is required for doing firmware updates, so definitely something that's worth picking up just so that you can do that very, very easily with that product. And then finally, of course, we have our 100 amp load panel, which is where we're going to put our critical loads. If we are AC coupling, then that's where we're going to be bringing our output of our PV inverters and connecting it to that battery-based solution. So again, can't say it enough times, the output of the inverter, which is going to be the grid forming inverter, needs to be connected to the PV inverter so that the PV inverter has that qualified AC source for creating power and providing loads both inside the home as well as charging those batteries. Next up, of course, we have our Connext SW. In this example, it's the North American. Again, we have our load panel, which is down below the Connext SW, along with transfer switches. So again, we'll just kind of walk through this equipment and talk you through what exactly we're seeing here. On the left-hand side, we have the MPPT 60 DC solar charge controller. Not necessarily the right match if you've already strung a high voltage PV array, but definitely good for a retrofit. Here we have the DC disconnect box and or the DC switchgear box, and what that allows you to do is, of course, connect and disconnect the DC source as well as the charge controller. And then there on the right hand side we have the SWNA with some very basic monitoring lights, so definitely still suggest using the SCP or the COM box or the COM box together. And then finally down below we have our AC switchgear. The nice thing with the AC switchgear is it actually has some extra slots, so you can actually bring in some extra DIN mount breakers, and those DIN mount breakers will allow you to use that solution as your critical load panel. Of course, you do need to be aware of some of the limitations when we start putting together an AC coupling solution. That switchgear box may not be enough room to meet UL NEC listings for backfeeding onto it. So you may still need that 100 amp panel down below. There on the right hand side, of course, we're starting just to the right of the AC switchgear, can be used as a subpanel for backup loads. To the right there, of course, we have our COM box. Down below we have our AGS. So again, if a generator is on site, this is what's going to allow the system to call on and start up a generator automatically when the batteries get low. Down below is the battery monitoring solution with our battery monitor, and then of course on the left is the SCP. So really, if I had to say minimum amount for what you need here, of course, is the AC and DC switchgear, the SCP, of course, and then if it's a remote location without internet, the SCP. If it's a local connection and you do have an internet connection, then definitely the COM box is the product to choose. Gives a lot of versatility and allows that remote monitoring. To complete the webinar, we're going to be talking about exactly what happens when we have an AC coupling solution and how that PV inverter really interacts with the energy storage solution. There really are two styles of AC coupling. There's the curtailing and non-curtailing. We'll cover the first part, which is non-curtailing PV inverter. So in this case, we have an inverter that is IEEE 1541 compliant. And what's going to happen is, of course, when we get to 60.5 hertz, the AC source is no longer qualified and that PV inverter is going to stop producing power. And so we can leverage that idea with the non-curtailing inverter by simply frequency shifting 1.5 volts below the bulk set point within the XW plus or SW. And so what's going to occur is that as the voltage gets above 1.5 volts below the bulk voltage, that frequency is going to start to shift. And it's going to start to shift until we reach that bulk voltage, and we're going to get to 60.5 hertz. At that point, of course, the IEEE 1541 PV inverter is going to disqualify that AC source and stop producing power. Then the battery voltage will start to decline, and then that frequency will also begin to decline. And the end result is going to be that the system is going to start requalifying the AC source produced by the Schneider electric inverter. In the example you see here on the right, of course, this was a test configuration. And so we continued to force the inverter to see the PV inverter's source, and the battery voltage continued to charge, and so the frequency actually began to rise well above that 60.5 hertz. But for most PV installs, this is going to hold true, that a non-curtailing PV inverter is going to see that frequency shift to 60.5 hertz and just simply kick it out. And so this is very, very important to understand when we're choosing the inverter, that we choose the right inverter that meets that UL 1541. With a curtailing inverter, this provides the best opportunity to manage batteries in the smartest way when we have an AC coupled solution. It really is a truly fully regulated charge. We can see here on the charts on the right that during a lower voltage setting, meaning the batteries have been partially discharged, we can actually go through a full bulk charge.
And at some point, we're going to see that the frequency will begin to shift as we reach our bulk voltage. And we're going to be able to hold that using those 20% increments to actually maintain and charge the batteries. And the really neat thing is that unlike the previous example where we're kind of just holding it there at bulk or plus 4 volts bulk, we actually know that the batteries have been taken care of, that we have a 1-hour absorb that's been programmed into the system. And so we can actually send that signal over to the PV inverters, and they'll actually then begin to curtail their power down and allow that system to actually go into float. And once we've hit float, we can put those batteries into a rest, essentially by turning off the PV inverter because we've created an unqualified source at 60.5 hertz. There are a few different inverters out there that are qualified. For North America, the SMA Sunny Boy makes for a nice pairing. So if you customer or site already has that, that's a good one to do, as well as for international, the Connext RL is a great solution as well. In our next webinar series, we will be talking a little more detail about some of the other compatible curtailing inverters, and we'll go into a lot more details about that. Before we end this webinar, there are some final points that I'd like to leave you with. You know, energy storage is worth investigating and looking at where those opportunities exist, either with providing backup power, AC coupling, or even the possibility of DC coupling and being able to get some of those advanced features, including load shedding and time of use and things like that. This is a great way to generate new sales, of course, with existing customers, because you've already identified who those customers are that you've done systems with. You can even go and talk to bids that you haven't won and check in with them to make sure that they understand that the system that's just a straight grid tie PV inverter solution isn't going to work when their grid goes out. So this is an easy way to not only follow up with your own customers, but maybe customers that you didn't win the first time around. Of course, the install and setup is fairly straightforward. Once you know and understand where to land things, of course, we've gone into that several times in great detail. And of course, setting those expectations early is very important, just simply because when we talk about energy storage, the more time and energy spent on making sure the customer really does understand how energy usage relates to available energy is going to go a long way. So again, that hot water tank heater, if everybody takes a hot shower in the morning and there's 5 of you, somebody may get a cold shower at the end of the day. That analogy holds true that if you have very large loads to begin with for a backup system, then that storage solution may fall short. Finally, when we look at creating customers or creating new sales, of course, DC coupling, again, provides that time of use. That's where that MPPT 80 charge controller can simply replace a PV inverter and be able to bring in that controlled charging. Finally, the security of the customer just simply means what we talked about in that very first slide, which is that the system itself is going to be able to provide power, of course, when the grid goes down, and that can keep people in their home instead of having to leave, especially during an extended power outage. So I want to thank everybody for coming to the webinar, and we look forward to seeing you the next time. We will be covering this in a part 2, where we'll be getting into programming command and control of the system. So please look out for the second webinar, and that should be coming out around May 25th with the video follow-up sometime in June. Thank you again so much.